Hello everyone, I'm Said. In this video, we are going to talk about dependency injection and how we can use it in our .NET applications. I'm going to walk you through all of the different aspects of dependency injection, common mistakes, and best practices for using .NET dependency injection. So let's start with what is dependency injection. Actually, is a technique for achieving inversion of control when we are talking about IOC is actually finding a way for managing dependencies, connections between different classes in a proper way, actually. So a dependency is an object that another object actually depends on. When we have a class that inside that class we are calling another class, it means that class has a dependency to another one. So the IOC is coming from one of the principles in solid, which is the last one, and actually one of the most important one. It is talking about direction of dependencies in applications should be in direction of abstractions, not from implementation details. What it means? It means every class that has a dependency to another class, it should be always dependent on a high level signatures contracts for the other like interfaces or classes, not dependent in a low level implementation. Later on, we're going to talk more in the code, but here IOC is just that, dependent on the abstraction, not implementation. This one in recent years causes lots of putting abstractions in our code, but still we need to have a certain level of abstractions in our code, but we should not go in that way to put everything under a interface or abstraction, right? So we need to keep a proper layer for the abstraction to make our code more maintainable and easy to read. Okay, so all this IOC is related to the dependency inversion in the solid principle. What it means here, there is a direct dependency graph that actually it is not a good practice. It means, for example, that class has a direct dependency to service A. Right here, we can see that the service A creating a new instance of service A, it means it is a direct dependency to service A. If in any code base you see some kind of new instance, new class, this is kind of a sign that you should not do that, or it is not a good practice to creating new instance like this. Actually, in the compile time and runtime, it is the same graph for the references and dependencies. What we can do is in turning that constructor from the direct dependency class to this way, we can create an interface like called iServiceA, and then the implementation, which is the service A class, is doing something. So our iService A is the abstraction. And then this direct dependency class is dependent on interface, dependent on the abstractions. It doesn't care about what is inside the service A or what the kind of methods doing some stuff there. It is only dependent on the high level, which is in definition of IOC. Okay, so this is the correct way of injecting dependencies to the classes. Here also in the right side, you can see in compile time, we can see the references in this way, but at runtime, our DI container will create the correct instance for us, but the code, it doesn't dependent on any implementation side. Let's go and talk about abstractions for the DI in .NET. All the DI implementation is based on three class or interface here. The first one is iService collection, which maintaining a list of services that we registered, like depends on lifetimes, anything related to our services that we already registered will be kept in the iService collection. And then we have another interface called iService Provider, which is responsible for providing those instances that we already registered. During the runtime, when we are running the code, always we ask service provider, okay, please give me, for example, this singleton service, give me this scope service. Later on, we talk about the lifetimes. The provider is responsible for retrieving the service object. Another one is service descriptor, which is the main class that is containing all of the information, the metadata about a service. For example, what is the interface? What is the implementation type? What is the lifetime of that service? iService collection is a list of service descriptors here. Okay. The .NET DI will control all the lifetimes of our objects. Generally, we have three lifetimes in our DI, dependency injection: singleton, transient, and scope. A singleton service will be created per application. It means singleton, once it creates an object, our DI, it will alive and will be there for whole lifetime of the application from the start until we shut down the application or restart the application. That's really matter to know. And then another one is transient. Transient is per injection. Every time that we ask from the service provider, give me an instance of the transient service, it will create a fresh instance for us. And then we have a scope service. Here I put the question mark because there are kind of misunderstanding about the scope lifetime. In the code, we're gonna talk about it more, but here in short, scope service, many developers saying that it is per request, which is not correct. Scope services will be created per scope, but in .NET Web API, for example, each request will have its own scope, so that for each request, we can expect that can get one scope service for whole the request lifetime. But again, we can create our own scope and then getting different services from that. Another one for the register services, simply we can say services dot add lifetime, for example, add singleton, scope, or transient, and then passing the interface and then the implementation type. Okay. We have different ways of resolving those services that already registered in the DI. First one is constructor from the class. It is the best way to actually resolving those services, asking service provider, I need these kind of services. So you need to creating the instance for me from the constructor. You know that constructor is the first place that will be called after the class has been instantiated. Another one is method injection. Maybe we don't want to inject the service from the constructor, but every time a specific method gets called, then we ask from the DI to resolve the services. In a very certain scenarios, we can use this one. We're going to talk more in the code. Again, we can actually using directly interface iService Provider. Another one exists is iService Scope Factory, which is a lighter one comparing to the service provider. It is recommended to use this one. We have another one in general in the dependency injection called for property injection, which is not supported in our built-in .NET DI. So now let's go and see the code in the ASP.NET Core API. I already prepared project. One is API, console, and domain. Domain is just containing some set of services here, like a singleton service, just has one method, print me, and then one implementation. In the constructor, I put this log here because I'm going to show you when it is created by the DI, we need to see this kind of logs. And then same happens for the scope service and also for the transient, the same. Let's see how we can use and register these services in our API. This is a simple template from the ASP.NET API. As we saw in the slides, we need to register our services in the DI by saying add lifetime, which is the first one is singleton. And then first we can say singleton service, which is the interface. And then we need to have the implementation type for it. Okay, this implementation should explicitly implements this interface. For example, if you put another one like scope service here, it will be showing error that it is not implementing this interface. Okay, so let's add all of these stuff here, scope service, and also for the transient one, transient. Yeah. Now we registered all of the services here and other ways for registering service to the DI. For example, here we can say add scope only class one. We can do that as well without any interface. That's fine. And also we can create a new instance as well, like this one. If you need something that needs to be instantiated by the class itself, that's fine as well. There is one trap here that later on I'm going to talk about it, but always it is good to use this kind of interface like implementation type unless you want to use less abstraction so that you can just only remove all the interfaces and then register your class only. So we register all the services here. Now we need to use them. So I have one controller here, one simple API. As I said, the best way is using constructor. So what we can do, we need to say read only I singleton service and then singleton. Another one is a scope service and transient service, right? Here, still, we didn't ask service provider to provide these instances for these abstractions. Actually, we need to put them in our controller constructor, our class constructor, right? So we need to put all of them here. Let's just put them here as well in the constructor. Okay, let's make it like this. It is better to be vertical. In the constructor, we are asking to resolving these services and then assigning to our local properties. It is always good to put read-only because after retrieving those services, we should not changing these instances from here. So it's always to good put read-only here as well. That's fine. So let's just run the project and then when asking from the DI, what happens? If I run the project here, I'm going to put it like this one. And then here is actually local host. Port number is 76 weather. This is called, gets called and returning the response. But here we can see these logs that I put in the constructor class. You can see singleton services created with a different GUID generated, scope services, and transient. Okay, still the application is running, right? So let's just call another time, and then we can see singleton didn't create it here because, as we said, singleton is only once per application. As long as our application is running, the same instance of singleton will be used in our classes. So when I trying to refresh the and calling the API, it is just scope services and transient services will be created. A scope service, as I said, is per request or per scope. And transient is every time that we ask service provider. So for example, if I, as we said, we can actually inject services from the method level as well. For that, we need to say from services. And if I just saying transient service here, because this is two different places for injecting, one from the constructor and then another one from the method. So let's call the API again. Okay, if I run this API, we can see one singleton created, scope, and then two transient, because one of them was in the constructor, another one is in the method level, right? So this different GUID number we can see. But if we inject iscope service, let's see what happens. Okay, we can call the function again. Here, scope service, although we injected from the method level, but it was in the same request. So actually, the controller first created and then called the get method. So when we creating the controller, the constructor level was called and created the scope service. And then another one was just reuse the same instance because it is the same request. Okay, but that's another stuff that I said there is some misunderstanding. Still, the scope service, we can create a different instance. For example, if I register the I service scope factory here, um, put it here. So now we can create a scope. This is our own scope. This is different from the request scope that coming from pipeline of the ASP.NET. So scope services too. So if I request for another object from the scope service, let's see what happens. Okay, so let's just call the API again. Here we can see one scope services from the constructor level in the here actually, and then another one is from here. So here we can see that when we say scope is per request is not correct totally. Scope services will be resolved per scope, but request itself is a scope. Okay, that's it for this one. Let's back to our slides. Another question is how about console application? We were talking about scope services will be resolved per request. But how about console application? Because there is no concept of request in the console application, right? Let's see. I'm going to go back to the code. Here I have one console application created. Again, we registered all these services. And also for the console application, when you are using DI, you need to actually using hosted services like background service or hosted service itself to run something. The point about the console application is all the services, all this like hosted service will be working as a singleton. In the singleton, later on in the slide, we will see there is one captive dependencies. You should not resolve a like a scope service within a singleton service because as we said, singleton will be alive for whole application lifetime. For example, here, if you want to resolve one scope service or transient service, it will be there until application shut down or restart the application, which is not good because you will have memory leak because you're creating lots of instances within the singleton, right? The best way here is if we want to resolve a scope service or transient service within the a singleton one, the best one is using that service scope factory and then just start resolving and creating your own services here. For example, again, we always need to use using because the scope is disposable so that we need to dispose after we are done with it. So, for example, scope service, yeah, or not singleton. Singleton, it is okay to resolve from another singleton, but for the transient one, we can get it from the service scope factory. Then once we are done, it will be kill all of these created instances. Okay, let me run the console application here. You can see these services created, transient created. This is the best way for dealing with the console application once it comes to the dependency injection. The only point you need to carry is everything in the console application will behave like a singleton. So you need to resolve your own scope and resolve your services. Let's continue now on our slides. Another question is iService provider has a lifetime as a singleton or scope? Because as we said, service provider is responsible for resolving all the types, all the instances for us. So it is making sense that it should have a singleton. It should be always there in our application, right? But it is not correct. Actually, in our .NET, we have two different iService provider. One is with the singleton lifetime and another one is with scope. What I mean here is when we are trying to resolve the services within a request, we are using the iService provider that is only created for this specific request. And it means it has the scope lifetime. But we also have another one in the root scope, which is responsible for retrieving those singleton objects. That is really matter to understand how it is working because different iService provider will help us to actually manage our service lifetimes and dispose them once it's done. If you're curious how we can find that service provider, the scoped one, here in the code, for example, in the controller, we have one HTTP contact. And then here we have a request services, which if you hover on that, it is also a service provider, but this one is actually the scoped one because it is specific for our request. So that one is just good to know when you are talking about the scope, the singleton. Service provider has two different lifetimes. I'm gonna just jumping back between code and the slides because it is good to see in the code the actual meaning. Okay, we have captive dependency. What it means? It means once we are resolving some services from another services, those instances will be there and actually is like a captive there, right? We need to understand it is should be from the higher lifetime and using them from the lower lifetime. What it means we can use a singleton either in a scope or in a transient service, but we cannot using the lower lifetime into the higher lifetime. Like we cannot use a scope service into a singleton because, as I said, singleton will be there for the whole application lifetime. And then that service for the scope or transient that should be disposed per request, for example, for the scoped one, but it will be there in the singleton object. So it is always very important. Actually, by default in the ASP.NET, it will check these captive dependencies when you are running in the development mode. So it is fine. I mean, it is always trying to check. For example, if I just quickly show you what I mean here. So we have, let's just put this one here. Um, we have a singleton, right? So here we have a singleton one. So if I want to, for example, resolve one scope service in the constructor asking um, from the DI to resolve this service, it will through exception. So let's just run the code here. So yeah, some services are not able to construct because while validating the services scope. It is good checking these kind of captive dependencies for us, and it is really matter. Cannot do that in the development, and either you need to disable this kind of stuff. But by default, it is checking, but you can disable it, but it is not recommended at all. It always should be like the way that I describe it. Otherwise, you will get memory leak. Let's go for the another point. One interface, two implementation. Wow, how can I do that? When we are talking about abstractions, it is a common thing that maybe I have one abstractions, but two different implementations. It is happening, right? But how we can manage this scenario? I have one email service, which is a very common example of these kind of stuff. For example, in your application, you have one iEmail service and then one kind of send email method, but you have two different email provider, email server, SMTPs in your application, like Google and Yahoo there. Each of them definitely will have different implementation. You will here sending your email requesting from the Google server, but here from the Yahoo mail server to send that email. But always, as we said, our controller in this case will only dependent on the high level. So you will have only one interface. And here in the classes, you just need to say email service dot send email, something like this. You can just say like this one, doesn't matter. Just putting some stuff here, mail.com. But at runtime, which one will be resolved? Google or Yahoo? For example, here we can register both implementation. That's fine. Let's put it as a scope. Here we have one Google, and then another one is Builder Services scope, and then again, yes. Already we register two different implementation, but for the same interface. Here is one point here. Let's see. Already we inject only the iMail service. Let's see how it works in the runtime. Okay, it is still there. Let's just clean up that singleton service because as we said, we cannot use scope service in the singleton. Okay, and then let's just put one breakpoint. First, we say Google, second one is Yo. Let's call the API again. Okay. Here, our email service is the Yahoo one, right? Not the Google. So this is the way that our dependency injection is working. Always, if you register multiple classes as an implementation for the same interface, it will be replaced for the previous ones. Like here, Yahoo will replace the Google if you just asking for a single one. So what I mean here is if, for example, I asking for the I enumerable of this service, this email service. And then at runtime, the DI will resolve all of these different implementations for me, like both of that. And then you can iterate in the method on your email services because you have one list of actually those implementation. But from the .NET 8, there is a better way of doing that exactly came for this reason. So we have a feature called keyed services. We can say add keyed scope. We can actually give a key for different implementation type. Same goes for the Yahoo as well. And then we can remove this too. And here we can remove the IEnumerable based on my preferences. For example, in this controller, I would like to get, you need to use this method from keyed service to resolve your services based on the key. It should be exact key that you passed here. It's actually like a dictionary for resolving the services. So here I want to get Google email for this specific injection from here, right? So let's run the code again and let's see which one will be resolved here. Okay, let's call this one. Now we can see the email service will be Google. So it is totally up to you based on the different logic in different classes. Maybe one you need to resolve the Yahoo one, another one is Google. So this is the way for resolving key services. Same goes for also the method injection as well. You can hear saying from key service to use for different implementation. Let's back to our slides. Let's cover another very important idea here, very important point, which is the thread safety in the singleton services. We talked about all the singleton instances will be alive for the application lifetime. What it means? It means once the singleton was created, it is reusable for all the application lifetime because all the requests will go to the same instance. You always need to handle the concurrency or the threads because it is only one instance, one object, a shared resource that in the definition of the concurrency or the multi-threading, once you are sharing the same object within different threads, you always need to care about this kind of thread safety. So this is really matter to handle either by lock or semaphore, depends on your logic in your code. But I just put it here to point out this is very important to handle. And actually, in my opinion, as long as you can, don't use singletons because they are really difficult to maintain, debug, this kind of issues for thread safety. So if you can use a scope service, please use scoped or transient if possible. Because singleton is good for the performance wise because created only once and then you will reuse it, but it will bring many difficulties as well. If it is possible, you can use another lifetimes as well. Let's talk about the most important misunderstanding for developers: disposal of services. We were talking about dependency injection in .NET, which is responsible for controlling the lifetimes. What it means actually, let's back to the basic. What it means when we are saying add singleton or add scope, it is all about disposing of those services by putting and specifying a lifetime for a service. We are telling the .NET dependency injection, once you create this object for me, when you can dispose it, when you can throw it away, because I don't need it anymore. Okay, this disposal for the singleton only happening once when you actually shut down or restart the application, but for the scope happening per scope, for transient again per usage for each services. But let's talk about what we meant here. For example, let's go here and then if I want to actually implement the iDisposable interface, I have to put something here. So let's just put another log here, like saying singleton dispose. And then for the our scope one, also let's just do the same for iDisposable. And then here, okay, console dot write line disposed. In our controller, we have the scope service here, right? And then another one here. This is the using, and we have a scope here. So we don't call here in the code nowhere for dispose, but it will be calling by the dependency injection actually. Let's just run the API again. Let's see what we have. So if I calling the request, let's see what we have. We have singleton created, scope created, and transient. And then we have scope, dispose, scope, dispose, because we have two different objects here. And then the DI, once the request is done, returning the response to the client side, it dispose all of the created scope services, right? So for the transient, we didn't implement the dispose interface, so it is no lock here. Let's call API again, because we created two services scope, we have two disposal of services, but the singleton is still there because the application is running. So once I shut down the application like this by Control C in the console, we can see another one, singleton service dispose, which is really matter. We have all the disposal here by the DI. But there is one trap here. For example, these services are totally fine, are creating by the DI and disposing by DI. But if I have something, as we said, there are different ways of registering the services into the DI. So if I doing registering like this at singleton and then directly creating one singleton service like this, right? So let's comment this one here. And now you as a developer are creating one instance for DI, and then you are responsible for disposing this service as well. Because DI is only taking care of those objects that was created by the DI, but now here you are explicitly creating a new object, right? So what I mean here is, as we saw in the previous one, once we shut down the application, this dispose method was called by the DI, but now let's see. If I run the application again, and actually we need to inject it to the constructor as well, actually the object, because we register the object itself, not the interface. And then here as well, we can be saying request the object, the class itself from the DI. Okay, let's run the application again and let's see. If I call the API, the singleton is here, right? Once we are actually creating a new instance here, it is creating the instance before the API, our application starts running. Here we can see the first log in our console before even the Kestrel starting. We have singleton created, but if we just call the API again, this will be reused. And now if I Control C in our console here, there is no like singleton service dispose, which we have it in the method here. So this is really important point for you, because usually in the dispose, you may have kind of disposing, releasing all the resources that you have taken from the operating system, like the network, like files, all this stuff. So this is really important to care. All the instances that you are providing for the DI, you have to care about disposal as well, because there is no control over this kind of stuff here. So here for this way is fine because DI will create one instance for you. But like this one, this is really tricky one. You need to be very careful about it. Okay, let's back to our slides. Actually, that is the last slides for me. So thank you so much for watching this video. I hope it was helpful for you. Leave a comment for me if you have another points, another trick of using dependency injection in .NET. Thank you so much for watching this video.